so brand new, early on, oh, and put your pencil down. Early on, it seems a little like intimidating because you've never seen and you don't know what any of this is. But as we get into it and you become more comfortable with it, I think most people tend to start to find it pretty easy. There's a couple like key things I think every question comes back to, and I think that can, I find that these questions on the exam are answered with a better accuracy rate than other topics. So we're starting with rotations and angle terminology. So we'll just read this. An angle is said to be drawn in standard position. So we'll be drawing a lot of angles in standard position if its vertex is at the origin, its initial ray always points along the positive x-axis, and its terminal ray has been rotated around the origin. So a positive rotation travel occurs counterclockwise and negative. So we'll come back to all this because it'll make more sense once you see it. Draw a rotation diagram for the following angles. State the quadrant in which the terminal ray falls. So every angle you ever draw has an initial ray along the x-axis. I'm just going to straighten up if I can. Just need a straight something. So and there's like a joint at the origin. And then you open it up in a counterclockwise direction until you get to 140. So how many degrees would that be? 90. How many degrees would that be? 180. So 140 is obviously somewhere between 90 and 180. So 140 would be somewhere out there. So what you will do is throw that terminal ray in the appropriate quadrant, wherever it falls, and you also do a little arrow that shows the direction in which you opened the angle. So you wouldn't write this on everything, but just so we know, that's the initial ray that we talk about, and this is the terminal ray that we talk about. And we're starting to ask you what quadrant does that lie in, because that's going to carry a lot of weight later in the chapter. What quadrant is that? 2. Remember your quadrants. 1, 2, 3, 4. Okie doke. Now, we'll come back to it, but that's a 140 degree angle. That's positive 140. We open clockwise or counterclockwise. This next one, by the way, this is a theta. This uses Greek letters to define your angle. So this angle here is theta. This next one is alpha. So again, your terminal ray always starts on the positive x-axis. This one is a negative 300. So I'm going to open up the opposite direction. What's this angle? No. Negative 90. But who said 270? Because you're not wrong. If I said, where's the 270 terminal ray, it's at the same spot. And so is the negative 90 at the same spot. So you're not wrong, but because we are opening in that direction, we're just going to think negatively for a second. Negative 90, we keep rotating around, that's negative 180. This would be negative 270, and so a little bit further would bring us to negative 300 before we got to a full circle, which would be negative 360. So we're going to put that right there. We're going to show that we opened up in that direction, and that's our alpha. Okay? Really quickly, if you're going the positive direction, that's always your 0 degree angle. This is your 90. This is your 180. This seems to be something that at least half of you already know. 0, 90, 180, 270. And 0 kind of coincides with 360, right? A 0 degree angle has a terminal ray right there, and a 360 degree angle has a terminal ray on the same location. Just like if we're opening up negatively, we would label that as a negative 90, a negative 180, a negative 270. So a 90 degree angle and a negative 270 degree angle are very difficult to tell the difference between unless you have this little rotational thing opening up and showing you which direction you went. Does that make sense? And then lastly, a 450. So we're opening positively. So there's our 0. Here's our 90, 180, 270, 360. That was one full circle. And then what? What's 90 past 360? 360 plus 90, what'd you say? 450. So actually that ends up landing right there. So here's your initial ray still. We actually opened up one full circle and then some. So our terminal ray ended there, and that was a 450 degree angle. So one vocab word that we're going to get to down at the bottom here is coterminal angles. When two things coincide, right, they fall on top of each other, right? Co-captains, you've got two people in the same position as a captain, right? Co-MVPs, you know all these terms, right? Coterminal angles are two angles that have a terminal ray at the same spot. Like a 450 degree angle is a coterminal to a 90 degree angle. Is also a coterminal to a negative 270 degree angle, because they all look the same. It's just how we got there that's different. They all have a terminal ray in the same spot, so that's a coterminal angle. This word doesn't really come up at all much that I've seen, but I do want to say what it means, because we were asked what quadrant is the terminal ray in, and so for this one it was quadrant 2. What quadrant was this one? Quadrant 1. And this one, if someone said, what quadrant is your terminal ray in, it would be tough to answer, because it's not in 1 and it's not in 2. It's on the border between them. That is what is considered a quadrantal angle. So if you see that word, that's what it means. It's not really in a quadrant, it's between quadrants. Okie doke? So a 0, a 90, a 180, a 270, or any coterminal to those that has a terminal ray on those axes is called quadrantal. Okay? So on top of the quadrant that the terminal ray falls in, hugely important, you'll see why as the chapter progresses. The other thing that's hugely important is a reference angle. Because the only true angles that you will really be required to know about and be asked about are angles between 0 and 90. And every angle has a reference angle. The reference angle is the positive, has to be positive, acute, that's a little bit of a stretch because it could technically be 90, but positive acute angle formed by the terminal ray and the x-axis. So a reference angle has to be, and I'll use a lowercase r, has to be between 0 and 90 degrees. Has to be positive, has to be acute, which pretty much those all are except for the endpoints. And let's read that description. It's the angle formed by the terminal ray and the x-axis. So let's go to this first one, the 140 that we did. Here's our terminal ray, which was at 140, and here's our x-axis. What's the angle formed by those? If this is at 140 and this is at 180, what's that? 40. 180 minus 140. It's just the difference between them. So your reference angle for this is 40 degrees. And we will talk reference a lot. Okay, on the second one, here's our terminal ray. That was at negative 300. We want, and I'll read it again, the angle formed by the terminal ray and the x-axis. Here's the x-axis, right? What's that measure? That's your reference. What is it? If I kept going with my rotation, I came around, this was negative 300, and I kept going, what would this be labeled? Negative 360. And what's the difference between negative 300 and negative 360? 60 degrees. So your reference angle is 60 degrees. See how your reference angle is always between 0 and 90? Between 0 and 90. Yes? Last one. Here's my terminal ray. And here's my x-axis. Now this one you can go to the x-axis on this side or on this side. You typically go to the closest x-axis, right? But this is, you know, half and half. So what is the angle between the terminal ray and the x-axis? 90. So your reference angle here equals 90, which is not technically an acute angle, but that's the biggest reference angle you could ever have. Okie doke? All right. And so now back to that coterminal. So a 140 degree angle, which we have here, we want to try to come up with a coterminal. So essentially, this has opened up from 0 to 140 pretty straightforwardly. How else could I open this up so that this terminal ray would land on that same location? I could first and foremost rotate it the other direction. So rather than rotating it counterclockwise in the positive direction, I would have to rotate it in the negative direction. How far? What's that so far? Negative 90. This is negative 180, and this would be negative... I already passed negative 140 because here's negative 90, and I keep going, and there's negative 180. So negative 140 would be down here. 220. Because you knew that this was 40 degrees further, right? Because we already talked about the reference angle. You knew that this was 40 degrees off. So we went negative 180, and then 40 degrees more would be negative 220. Does that make sense? So negative 220 is one option. Now here's what else I could do. I could open up still in that positive direction, but I could go around a full circle and then that additional amount to land on it. So the full circle would be going around 360 plus an additional 140. 360 plus 140 would put me at 500. So that's another coterminal option. Here's the, realistically, there are a gazillion coterminals, because if I can go around one full circle and then some, I can go around 2 full circles and then some, or 3 full circles and then some. In the positive direction as many times as I want, or in the negative direction as many times as I want. You can get a coterminal by adding or subtracting 360 degrees as many times as you want, k times. I can add 360 once. So 140 plus 360. That's a coterminal. I could add 360 twice. That would be 860 is a coterminal. All of these angles end at that same terminal ray location in the second quadrant. And I could also subtract 360, and that's really what we did the first time to get negative 220. We thought of it differently, but that's really what we did. You could subtract 360 twice. You just have to make sure it lands in that same spot. So whatever one, wherever that is, you can add 360 onto it, subtract 360 from it to get coterminals. So negative 300, if we wanted to just add 360 onto that, that would be a 60-degree angle. We could add 360 to that, add a second 360, and that would be 420. We could subtract an additional 360. So if it was negative 300 and we subtracted 360, we'd be at negative 660. All of these end at the same spot. This is where Chris Brooks and Lucas were both correct when they called this. Where did you disagree? Oh, someone said 270, someone said negative 90. That's because they're coterminal, so it could be perceived as either. Does that make sense? And then for 450 If I just subtract 360 off of that, I'd get 90. I could subtract 360 off of that again. I could get negative 270. It only asked for one coterminal angle. I'm giving you multiples. So if I just said, give me a coterminal, there could be 27 different answers. If it's a multiple choice, they might phrase it, which of the following is not a coterminal? You know, they give you 3 that are and 1 that's not. Any questions? You look bored. Is it too easy? We got to start small here. Okay, so determining the reference angle. We already did all that for these 3. We already did all that. Negative 180. So most of the time, guys, you're going to sketch your own rotation diagrams. So here's your initial ray. And if it's negative, I'm opening downward. So tell me when to stop. Negative 180. I went too far, right? Negative 180 is right there. So to show that rotation diagram, we'll show that we went that direction. And then process the reference angle. What is the angle between the terminal ray, which is here, and the x-axis, which it's sitting on top of? 0 degree reference angle. Reference angle equals 0. That's the smallest reference angle you'll ever have. 0 is the smallest, 90 is the biggest. Capiche? Okay. What quadrant is that in? It's not. It's quadrantal. Okay? So for each of the following in these exercises below, given by some Greek letter, theta, 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 these are all theta, draw a rotation diagram and identify the quadrant that the terminal ray falls in. So we've been doing a lot of that already. And exercise 5 down here, for each of the following angles, beta, that's a capital B in Greek, beta, draw a rotation diagram and then state the reference angle. So, I would like Jason, I want your row to do these 4. Got it? Owen, I want your row to do these 4. Vince, you do these 4. And everyone behind you do those 4. Chloe, these 4. And everyone behind you. Kate, you're back to column 1. Mike, you're back to column 2. Sierra, you're back to column 3. So do the 4 that apply to you. All right, Jason. Top part A. What quadrant? 2. And that's it, right? Q2. Because there's 180. So we opened up Q2. Very good. Oh, and B. I don't think so. Here's your initial ray. And, okay, where's my little paper clip? If I start opening up, what's this? 90. That's 180. That's, and that would be, you went the wrong way. So positive, you have to open up. Okay? So what quadrant should it be in? 4. Correct. Q4. Vince, C. 1. 0 to 90, so it's obviously somewhere in there. Right there. Hold on, I gotta do my little rotation. That's Q1. Very good. Chloe, D. Negative 210. So we are opening this way. There's negative 180. Or negative 90. There's negative 180. This would be negative 270, which is too far, so we're at negative 210. Very good. Q2. 1, 2, 3, 4. Good. Kate, E. 250. So there's 0, 90, 180, 270. So we have to stop shy of 270. Very good. So that would be Q3. F. Tess. Negative 310. We're going this way. So negative 90, negative 180, negative 270, and I don't want to go quite as far as negative 360. Very good. Q1. G. Sierra with a C. 460. So this is opening in the positive direction. That's a positive 460. So positive 90, 180, 270, 360, 450, and then just a little bit past 450. So that would be a, did you say 2? Good girl. And Jack, H. Yeah. Sorry. What quadrant? Didn't you have to do the fourth? Oh no, you were the first. You were the first. Who did I just leave off on? Lucas, B. Fourth quadrant. Let's see. So here's negative 90, negative 180, negative 270, negative 360, and that would be negative 450. We don't want to go quite that far. Q4. Good. Any questions? Okay, reference angle. First thing you want to look at, everybody, on your reference angle ones, did you give me a reference angle between 0 and 90? If you ever gave me a negative reference angle, it's wrong. If you ever gave me anything over 90, it's wrong. Okay? That's issue number 1, and then we'll see about our values. So now, Jack, what'd you get for this one? 20. So we open up to 160, which is in Q2. If that's 160 and that's 180, 20 degrees would be correct. Good. B, Lucas K. Okay, so what quadrant was your angle in? The fourth. So that was 300. And the nearest x-axis is this. What would be the label on this? And what's the difference between those? Did you say 50? Do you know why? Okay. Should be a 60 reference. And, oh, Eric, what'd you put for this one? 30. So we open up. Here's 180. Here's 210. So the closest x-axis was this 180 that we passed. How far apart is 180 and 210? 30 degrees is correct. Nice. Natalie. So what quadrant was 78 in? The first. And the terminal ray to the nearest x-axis is here. Who can guess what she did? This is a common mistake. Yeah. Right, you went to the y-axis. The reference angles never go to the y-axis. Okay, but that's a common mistake, so I'm glad it came up. It's the nearest x-axis to that, so what's the angle? Still 78. First quadrant ones are nice, because whatever the angle is, that's the reference angle. You don't have to do much thinking. Part E. Where are we? Back to the first. Olivia. 70, so let's see. So here's negative 90, and here would be negative 180. So negative 110 is definitely down here. That would be negative 180, and that's the closest x-axis. So that is a 70-degree reference angle. Very good. In F, Jack T. 80, let's see about that. There's 0, negative 90, negative 180, negative 270. So negative 280 would be here. What'd you say? And that's negative 360 if we keep going. And that's the closest x-axis, so that is correct. 80 degrees. Nice job. Ooh, 605. We're slim pickings on the ones. Jason, we're back to you. Or wasn't that your row? Oh, this is my threes. 1, 2. Haley. 65. Hold on, I gotta do some thinking. This is 360. 450. 540. I'm gonna label that. 630. So 605 would definitely be in here. And 605 from 540 is 65. Well, it sounds like you get it. And the last one, 1, 2, 3. Alexa, what'd you get? 50. And what quadrant was it in? Fourth. Negative 360. Get that out of the way. Negative 450. So she's definitely right with the fourth quadrant. And the difference between that and the x-axis, 50 degrees. Well, that's a beautiful thing. All right, we get it? Start basic. Oh, Elena is so over this. It was too easy. But it's just different. We have to